parallel and perpendicular lines. So this lesson is all about what they are, how to use them to solve problems, how to write equations with them, and all that good stuff. So first, let's talk about parallel lines. Parallel lines are lines that never intersect. So you see them like this, and then like that, right? They never cross. They're gonna have the same slope. Very, very important. That's probably the most important, not the most important thing, but that's a very key component. Is they have the same slope, but they have different y-intercepts. The symbol for that, for parallel lines, you'll see this. So that's the symbol. Okay, perpendicular lines. Perpendicular lines are kind of the opposite of that. They're lines that intersect at specifically right angles. So they make right angles when they cross. So like this, but right here they make a right angle. Those are perpendicular lines. They have opposite reciprocal slopes. I like to say they have negative reciprocal slopes. So you flip it. If it's positive, make it negative. If it's negative, make it positive. You flip the slope, and then you do the reciprocal. So negative reciprocal slopes. I want to spell reciprocal all the way out. So very important. The symbol for them is like a upside down T. So that's a perpendicular symbol. To give an example of perpendicular slopes, I probably should have done this earlier. Let's say the slope of one thing is 2. The perpendicular slope would be negative 1/2, right? So you flip it upside down and you change the sign. Here we go, right? There's some parallel, there's some perpendicular slopes. Right, you can see here they cross at a 90-degree angle, and here they're never gonna cross. Okay, first example, write an equation in slope-intercept form of a line parallel to the given line. So writing an equation of a line that's parallel to y equals negative 2x plus 5, but that passes through the point 3 negative. You heard me, right? I said write the equation of a line. Anytime I see that, we automatically go to my favorite one, y minus y1 equals mx minus x1, right? We're gonna write an equation of a line. All we need to do is write this and fill it out, right? We gotta find out the y1, the x1, and the slope. x1 and y1 are the easy parts. They gave it to us, x1, y1, so 3, negative 2. But how about the slope? The key here is it said parallel. And what do we know about parallel slopes? They have the same slope, right? Parallel slopes are the same. So if it's parallel to this slope, that means that the slope here is negative 2, that our slope, our parallel slope, is also going to be negative 2. And there we go, we're done. So that's all it is. You write the equation of a line. If it says parallel, that means you have to have the same slope. Now in this case, this is easy, it's right there. So our slope is going to be negative 2. But that's a context. So now with that in mind, let's go to the next one really fast. So same idea, write equation of a line. So I write my favorite equation, y minus y1 equals m x minus x1, right? Makes it really easy to make an equation. They give us a point, 8, 1. So x1, y1, 8 and 9. And then they tell us it's parallel to this equation here. So the slope of this equation here is 3, negative 4. And since it's parallel, it's going to be the same. 3 over 4. Did I say negative 4 last time? Anyway, y minus 9 equals 3/4 x minus 8. And there we go. Let's move on to perpendicular. So understanding slopes of perpendicular lines. So here are two perpendicular lines. And like we talked about before, if you look at these slopes, right, the slope of this line here, you can kind of see it, is 3 over 4, right? Rise over run. So we're going to go run 4 and we're going to rise 3. If we look at the slope of our red line here, remember you go left to right. We're going down 4 and then right 3. So slope here, m2, is negative 4 over 3. Now perpendicular slopes are negative reciprocals. So look at this one. If I flipped it, I'd get 4 over 3, and then you change the sign, you get negative reciprocals. Another way to think about that is perpendicular slopes. If you multiply them, you should get negative 1. So if that happened here, right, if I multiply 3/4 by negative 4/3, look what happens. They cancel. These cancel. You get negative 1. So that's perpendicular slopes, right? I always think about it as negative reciprocal. So if you get the slope of one of them, flip it and change the sign. You can also think about it, they multiply to get negative 1. why does it make sense that slopes of perpendicular lines have opposite signs? They're going opposite directions, right? One is going up or increasing while the other one's decreasing. So one is increasing and one is decreasing. So that's why it makes sense. Are there any exceptions to this pattern? Ooh, tough question. There actually is an exception to this pattern. And that is when we did this in the last video, when we're doing horizontal and vertical lines, something like m equals 2, let's say y equals 3, right? The slopes of these are not going to have opposite signs because one of them has a slope of 0, y equals 3 has a slope of 0, and one has no slope, right? You can't walk up a wall, so no slope. So it's not true when it's vertical. Are there any exceptions to this pattern? Vertical and horizontal lines, right? So that's not going to hold true. They are perpendicular. They do cross at a negative angle, but they're not negative slopes. Horizontal lines. So they do cross at 90-degree angles. They're just not going to have, one doesn't even have a slope, so it's not going to work. Anyway, let's move on. Same type of problem we did before. Write an equation in slope-intercept form of a line perpendicular to the given line. I think I might say that last time. I forgot to do it. So we'll do it this time, though. So we have to write it in slope-intercept form. So we have to simplify a little bit. But same general concept, right? Write an equation of a line perpendicular this time to this that goes through this point. So write an equation of a line. You know I'm here for it. Y minus y1 equals mx minus x1. Easy points, right? Our point is x1, y1, so 4, negative 1. And then our slope, now remember, it's perpendicular slope. So slope here is 2. We want the perpendicular slope, right? So the slope is 2. My perpendicular slope is going to be, flip it and change the sign. So negative 1/2 is going to be my slope. So we're going to have y plus 1 equals negative 1/2 x minus 4. Now last time I stopped there, I forgot that it said put in slope-intercept form. So if they want a slope-intercept form, we got to get y by itself. So let's distribute this. I know it's a fraction, but we'll be okay. So y plus 1 equals negative 1/2 x. Negative 1/2 times negative 4. So that's going to give us negative 4, positive 4 over 2. 2 negatives make a positive. 4 divided by 2 is 2. So like that. Right? So remember, this is like 4 over 1, if you're not sure. Then you just multiply across. So negative 1 times negative 4 is 4. 2 times 1 is 2. Then reduce it. So we have that. And then we got to get y by itself. So minus 1. So y equals negative 1/2 x plus 1. So that's the idea. Let's do one more of these. Let's stop like that. We'll go a little faster now, right? Same idea, writing equation of a line. So I'm going to go y minus y1 equals m x minus x1. They give us the point. It goes through the point x1 and 7, so x and y. And it's perpendicular to this guy. So my slope here is negative 1/4. My perpendicular slope, flip it, change the sign. So that's become 4, a positive 4. We're going to get, right? So we flip it to just, so we take the sign out, change the sign, and then flip it. So we have that. Now let's rewrite it because they do want it in slope-intercept form. So we got to get y by itself. So distribute the 4, y minus 7 equals 4x minus 4. Let's get that y by itself. So we're going to add a 7 to both sides. So plus 7 plus 7. I get y equals 4x plus 3. There we go. Next, classify the line. So are the graphs equations parallel or perpendicular or neither? So remember, parallel is the same slope. Perpendicular is negative reciprocal, so flip it and change the sign. And then neither is none of those. Neither is else. If it's not this or this, it's neither. So that's the idea. So look at this first one here, right? Y equals, well, first let's find our slopes. Our slope here is negative 3. Our slope here, I don't know the slope of this one yet. It's not in slope-intercept form, right? Slope, it has to be in slope-intercept form. This is one of the reasons we love slope-intercept form, why it's so popular. It makes it really easy to find slope, but it has to be in that form. I don't have that form yet. So first, let's put this in slope-intercept form. Try and trick me. So we're gonna minus 3x from both sides. These will cancel. I get y equals negative 3x plus 5. And now I know my slope is negative 3. And they match, so these are parallel. Okay, next one. So again, this one I know the slope already. Slope is 1/2. I do not know the slope of this one yet. I gotta get y by itself. So let's do that. So let's subtract the 4x from both sides. You get 2y equals negative 4x plus 6. Then we're going to divide everything by 2. So we get y equals negative 2x plus 3. Again, all I really care about is the slope, which is this guy right there. So my slope here is negative 2. And those are negative reciprocals of each other, right? If I flip this and change the sign, I would get negative 2. So these are perpendicular. Okay, one last one. Let's do an application problem. A landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path. So here's my east path. So they want like a fountain path that's like perpendicular. The new picnic will be parallel to the fountain path. Oh, so there's gonna be a picnic one that's like parallel to it. Interesting. That's not a very good parallel. I'm sorry. The picnic path will be parallel to the fountain path and pass through the picnic area. Okay, yeah. What are the equations in point slope form to represent these new paths? Okay, let's remind everyone of my favorite path, right? Point slope, my favorite equation, y minus y1 equals m x minus x1, right? So remember, when we have this form, we need two things. We need a point, x1, y1, which we have here, right? Our picnic area, we have our point 5, 6. I'll write right here so we can see it, 5, 6. We have it for our fountain area. That is, looks like it's 15, 2. So those are our points. And we need a slope. That's the thing we don't have, right? So I don't have a slope for this guy or this guy, but I could be able to find the slope of the east path, right? Because they gave us a line. So first, let's find the slope of the east path. And remember, rule number 1, if you're trying to find the slope, right, we need two things, really. We need 2 points. Right? If you want to find the slope of a line, you need at least 2 points. Remember, how does that work when you just have a line? You're looking for things that cross nicely. So it looks like right here, we start at 0, 2. And I need another point that crosses nicely. It's like this, I don't know what that is. I don't know what that is. Don't know what that is. Right here, that does cross nicely. That looks like the point 5, 3. Now again, you have two choices. You could use slope equation, y2 minus y1. That would be m equals y2 minus y1 over x2 minus x1. Or we could do rise over run. Looks like we run 5 and we rise 1. So my slope here would be 1 over 5. Again, you could do either way. You could plug points into the slope equation, or you could do rise over run. So keep in mind when you do that, run is on the x, right? Rise is on the y. So we went on our x, we went 5, and then we went up on our y1, so 1 over 5. Now they want the equation of the fountain path. So write our equation, y minus y1 equals m x minus x1. Our fountain path is right here. It's perpendicular to the east path. So remember, if it's perpendicular, I need a perpendicular slope. So I need to flip that and change the sign. So negative 5 is my slope, right? Because it's perpendicular to the east path. And then my point is this 5, 15, 2. So y minus 2 equals negative 5 x minus 15. There we go. Now let's find the equation of the picnic path. Here's our picnic path. So that one's parallel. So we're going to use the same slope that we started off with. Right, so it's parallel to that one. So we're going to use that as our slope. And then the point they gave us was 5, 6. So we get y minus 6 equals 1/5 x minus 5. And that's how we do it. That's the video.